All right, so this is your review for your quiz tomorrow, which covers 1.7 Part 2 and 1.8. We're going to start by looking at these inequalities, and we're going to solve them, graph them, and write our answer in interval notation. If we look at example 1, we have x squared minus 7x is less than or equal to 18. With all of these, you want to make sure they're equal to 0, or less than or equal to, greater than or equal to, less than, greater than 0. So you want to start this one by moving that 18 over. It is positive, so we're going to subtract it from both sides. This is going to leave us with x squared minus 7x minus 18 is less than or equal to 0. If you look at this, that less than or equal to means what? And or? Less than and. So the way that your lines are going to go is most likely going to be in towards one another. So if you solve this by factoring that x squared minus 7x minus 18, what are your factors of negative 18 that add up to be negative 7? Negative 9 and 2. So this is going to be x minus 9 times x plus 2 is less than or equal to 0. If we set them both less than or equal to 0, we're going to have x minus 9 is less than or equal to 0, as well as x plus 2 is less than or equal to 0. We solve them both. Move the 9 over by adding it to both sides. You have x is less than or equal to 9. Subtract the 2 from each side. You have x is less than or equal to negative 2. So on your number line, you're going to have a negative 2. You're going to have a 9. What's going to go on both of these numbers? Open circle or closed circle? Closed. And then which way did we say our lines are going to go? In towards each other or away from one another? In. So test a point or test a number. The number between negative 2 and 9 is? Pick an easy one. 0. If you plug in the 0, you have 0 squared minus 7 times 0, which is going to give you 0, is less than or equal to 18. Is that a true statement? Yes. So you know where your shading is correct. Write this in interval notation now. What's the smallest number that that line is covering? What's the largest number that line covers? Is it including the negative 2? So bracket goes on the negative 2. Does it include the 9? So the bracket goes on the 9 as well. For number 2, you have 2x squared minus 3 is greater than 5x. Your 5x needs to be moved over. So how are we going to move that 5x over? Subtract it from each side. So this gives us, bless you, 2x squared minus 5x minus 3 is greater than 0. Factor this out. You have an a that's something other than 1 without a greatest common factor that you can factor out. So multiply your a, which is 2, and your c term, which is negative 3. That gives you negative 6. What are your factors of negative 6 that add up to be negative 5?
Negative 3, negative 2.
Those are same signs, so when you multiply them, they're going to give you a positive 6, not a negative 6. So try other ones. Negative 6 and 1 give you that negative 5. So this factors out, or sorry, it doesn't factor out, but it expands to be 2x squared plus x minus 6x minus 3 is greater than 0. Now that you have 4 terms on that one side, you can factor by grouping. Between the 2x squared plus x, what's your greatest common factor? Just x. Between the negative 6x and the negative 3, your greatest common factor is negative 3. So this is going to give us x times 2x plus 1 minus 3 times 2x plus 1 is greater than 0. Because your two sets of parentheses are the same, we can rewrite this as 2x plus 1 times x minus 3 is greater than 0. What we didn't do from the very beginning is we didn't look at that inequality sign. You have greater than. If you're a greater or, it means what kind of statement are you going to have? Greater or.
And.
It's an or. Greater or. So your two lines are going to go away from one another. if you continue with this and just solve it, you're going to have 2x plus 1 is greater than 0, as well as x minus 3 is greater than 0. So for the 2x plus 1 is greater than 0, subtract your 1 from each side. You get 2x is greater than negative 1. Then divide each side by the 2, and you get that x is greater than negative 1/2. For the x minus 3 is greater than 0, add your 3 to both sides. You have x is greater than 3. So on your number line, you're going to look for the negative 1/2. You're going to look for 3. We said it was greater or, so your two lines are going to go away from one another. However, what's going to go on the negative 1/2 and the 3? Is it going to be an open circle or a closed circle? Open, since it's not also equal to. And then we said your lines are going to go away from one another. If you test a number between the negative 1/2 and the 3, it would be 0. If you plug that in, you would have that 0 minus 3. So negative 3 is greater than 5 times 0, which is just 0. So negative 3 is greater than 0. That's a false statement. There should be no shading in between there, which is what you have. So using your interval notation, give your answer for this. What is the smallest number that you're going to on the left side? Bless you. Negative infinity. Up to negative 1/2. Does it include the negative infinity or the negative 1/2? No. So parentheses go on both. We have another set that we're going to include with this. So this is going to be a union from 3 to positive infinity. And parentheses go on both of those as well. All right. For number 3, we're given 3x cubed minus x squared is less than 12x minus 4. Your 12x and your minus 4, you need to move over to the other side. So we're going to subtract the 12x from each side. We're also going to add the 4 to each side. So this is going to give us 3x cubed minus x squared minus 12x plus 4 is less than 0. You have 4 terms now on that left side, so factor by grouping. Between the 3x cubed and the negative x squared, what's your greatest common factor? X squared. Between the negative 12x and the 4, what's your greatest common factor? Negative 4. So this is going to give us x squared times 3x minus 1 minus 4 times 3x minus 1 is less than 0.
So if the right one is negative 4, why is the left one was negative 12x, and then it was plus 4?
So because that 12x is negative, you want to factor out a negative with that 4. You want that first term to be positive inside your binomial. Okay. So this is going to get rewritten as x squared minus 4 times 3x minus 1 is less than 0. Is this completely factored out? It is not. So if we factor this x squared minus 4, it's a difference of squares. So it's going to give us x minus 2 times x plus 2 times 3x minus 1 is less than 0. Set them all less than 0. You have x minus 2 is less than 0, x plus 2 is less than 0, and 3x minus 1 is less than 0. Now with this one's a little different than the first two that we did because this is giving you 3 different things that your equation or your inequality is equal to. So like I said, this one's a little different. With these, you have to test them. Some of you got a question like this in your practice on web science, some of you didn't. So like I said, sometimes you'll get this, sometimes you won't. Solve all 3 of them. For the x minus 2 is less than 0, add your 2 to both sides. You have x is less than 2. For your x plus 2 is less than 0, subtract your 2 from both sides. You have x is less than negative 2. Then for the 3x minus 1 is less than 0, add your 1 to both sides. You get 3x is less than 1. Then divide everything by the 3. You have x is less than 1/3. for this, write down your numbers. You're going to have 3 of them at least on your number line. One is the -2, one is the 1/3, and one is 2. Find numbers in between and on the outside of these numbers to test, so you know which way your lines are going. First off, what should be on all 3 of these numbers? An open circle or a closed circle? Open. For something that is x is less than 2, or sorry, the -2, far left. If you pick a number to the left of -2, that would be something like -3. So if you plugged the -3 in, you would have 3 times -3 cubed minus -3 squared is less than 12 times -3 minus 4. The -3 cubed is -27. The -3 squared is 9. The 12 times -3 is -36. And we have that minus 4. The 3 times -27 is what? -81. Minus 9 is less than -36 minus 4, which is -40. -81 minus 9 is what? -90 is less than -40. Is that a true statement? Yes. So we should be shading to the left of that -2. Pick a number between -2 and 1/3. 0. Perfect. Easy. So we would have 3 times 0 cubed minus 0 squared is less than 12 times 0 minus 4. The 3 times 0 cubed is 0, minus 0 squared is 0 minus 0. 12 times 0 is 0 minus 4. So it's giving you 0 is less than -4. Is that true? No. So there should be no shading in between the -2 and the 1/3. Pick a number between 1/3 and 2. Pick a number between 1/3 and 2. That's easy. 1. So that's 3 times 1 cubed minus 1 squared is less than 12 times 1 minus 4. 3 times 1 cubed is 3. Minus 1 squared is minus 1. Is less than 12 minus 4. 3 minus 1 is 2. 12 minus 4 is 8. Is 2 less than 8? Yeah. Yes. So in between these should be shaded. For a number greater than 2, pick a number greater than 2. That's easy.
3.
Positive 3. So this is going to give us 3 times 3 cubed minus 3 squared is less than 12 times 3 minus 4. We said that 3 cubed is 27 times 3 is 81. The 3 squared is 9. 3 times 12 is 36 minus 4. 81 minus 9 is what? 72 is less than 36 minus 4 is 72 less than 32? No. So there should be no shading to the right of that 2. So based off of what we have here, from the left to the right, what is the smallest number that's being included with these lines? Negative infinity. So negative infinity automatically gets the parentheses. From that negative infinity, what is it going up to? -2. Is the -2 included? Does it have a closed circle? No. So what goes on the -2? Parentheses. You have another part that you need to include. So what's going to go in between your 2 parts? A union. So you put that U there. For your next part, what's the smallest number that you're including? The 1/3. Does it actually include the 1/3? No. So parentheses goes on the 1/3. What does that line go up to? Positive 2. Does it include the 2? No. So the parentheses goes on the 2 as well. So your interval notation for this would just go from negative infinity up to -2, not including the 2, with a union of 1/3 to 2, not including the 1/3 or the 2. For number 4, we have 6x squared minus 3x plus 10 is greater than or equal to 4x squared plus 15. All of your terms are not on the same side here, so move them all over to be on the same side. I would subtract the 4x squared and the 15 from both sides. So I would subtract the 4x squared from the 6x squared and the 15 from 10. This is going to leave us with 2x squared minus 3x minus 5 is greater than or equal to 0. Greater than or equal means what? And or. Greater or. So away. You do not have an a of 1. So multiply your 2 and that negative 5 to get negative 10. What are your factors of negative 10 that add up to be negative 3? 2 and negative 5 give you negative 3 when you're adding them together. So this expands to be 2x squared plus 2x minus 5x minus 5 is greater than or equal to 0. You have 4 terms, so factor by grouping now. Between the 2x squared and the 2x, what's your greatest common factor? 2x. Between the negative 5x and the negative 5? Negative 5. So this is going to get rewritten as 2x times x plus 1 minus 5 times x plus 1 is greater than or equal to 0. This then gets rewritten as x plus 1 times 2x minus 5 is greater than or equal to 0. Set them both greater than or equal to 0 and solve them. So you have x plus 1 is greater than or equal to 0, as well as 2x minus 5 is greater than or equal to 0. For the x plus 1 is greater than or equal to 0, subtract your 1 from each side. You get x is greater than or equal to negative 1. For the 2x minus 5 is greater than or equal to 0, add your 5 to both sides. You have 2x is greater than or equal to 5, and then divide each side by the 2. So x is greater than or equal to 5 over 2. On your number line, you're going to have that negative 1. You're going to have the 5 over 2. What goes on both of these? Open or close circles? They're greater than or equal, so close circles on both. We said since it's greater or, these two lines are going to go away from one another. Test a number. A number between the two numbers that you have there is 0. If you plug the 0 in, that gives you 10 is greater than or equal to 15. Is that true? No. So the shading should not be where that 0 falls, which is in between the two numbers. So what your shading is right now is correct. To write this in interval notation, you're going to go from negative infinity up to negative 1, including the negative 1, so that gets the bracket, with a union of 5 over 2, including the 5 over 2, so the bracket goes on that, to infinity. For the next set of questions, you're working with absolute value. Remember with these, your absolute value cannot be less than or equal to, less than, or just equal to a negative number. For number 4, you have the absolute value of 3x plus 4 plus 5 is greater than or equal to 3. First thing we got to do is isolate the absolute value. So that 5 has to be moved over. How are we going to move that 5 over? Subtract it from each side. So this gives us the absolute value of 3x plus 4 is greater than or equal to negative 2. You have the absolute value of something, which is always a positive number. So a positive number is greater than or equal to negative 2. Is this true sometimes, always, or never? The absolute value of something. So a positive number is greater than a negative number. It's always true. So since this is always true, we have all real numbers for our answer, which means in interval notation, it goes from negative infinity to positive infinity. So on the number line, if you were to graph something like this, you would just have a line that goes the entire distance of that number line. But again, your answer in interval notation would be from negative infinity to positive infinity. For number 5, you have 2 times the absolute value of x minus 1 minus 4 is greater than or equal to 2. What's the first thing that you're going to move over in order to isolate this absolute value? The negative 4. So we're going to add it to both sides. This gives us 2 times the absolute value of x minus 1 is greater than or equal to 6. From here, what are we going to do? Divide each side by the 2. So this leaves us with the absolute value of x minus 1 is greater than or equal to 3. Is this possible? The absolute value of something is greater than or equal to 3? Yes. So separate it into 2 inequalities and solve for both. Remember, when you do this, get rid of the absolute value bars, change the sign on your answer. So it's going to be x minus 1 is less than or equal to negative 3. And then do one without the absolute value bars, keeping the sign and the 3 the same. Solve these both. For the x minus 1 is less than or equal to negative 3, add your 1 to both sides. You get x is less than or equal to negative 2. For the x minus 1 is greater than or equal to 3, add your 1 to both sides. You get that x is greater than or equal to 4. So on your number line, you're going to have the negative 2. You're going to have the 4. What goes on both of these? Open or closed circles? Closed, because they're also equal to. And then which way is your line going to go? Your 2 signs point away from one another, so your lines would go away. If you were to test, you can look at this. A number between negative 2 and 4 is 0. If you plug in the 0, you would have 2 times the absolute value of 0 minus 1, which is the absolute value of negative 1, which is just positive 1. So 2 times 1 is 2 minus 4. 2 minus 4 is 0. Or sorry, 2 minus 4 is negative 2. Negative 2 is greater than or equal to 2 is not a true statement, so you know that the shading in between should not be there. So put this in interval notation. You're going from negative infinity up to negative 2, including the negative 2, with a union of 4, including the 4, to positive infinity. For number 6, you have 2 times the absolute value of 4x minus 1 plus 3 is less than or equal to 9. First thing you're going to move over is the 3. So we'll subtract it from each side. You have 2 times the absolute value of 4x minus 1 is less than or equal to 6. From here, divide each side by the 2. So you have the absolute value of 4x minus 1 is less than or equal to 3. It is possible for the absolute value of something to be less than or equal to 3. So separate this into 2 inequalities. You're going to have 4x. I'm going to move over here. So 4x minus 1 is greater than or equal to negative 3, as well as 4x minus 1 is less than or equal to positive 3. Solve them both. Add your 1 over to both sides. You have 4x is greater than or equal to negative 2. Then divide each side by the 4. You get that x is greater than or equal to negative 1/2. For the 4x minus 1 is less than or equal to 3, add your 1 to both sides. You get 4x is less than or equal to 4. Then divide each side by the 4. So x is less than or equal to 1. Your 2 numbers on your number line are going to be negative 1/2 and positive 1. What kind of circles go on both of these numbers? Closed circles, because they are also equal to. And then which way is your line going to go? In towards each other or away from each other? It goes in. If you wanted to test, pick a number between negative 1/2 and 1. 0 is one of them. So if you plug in the 0, you're going to get 2 times the absolute value of negative 1, which is 2 times 1. That's 2 plus 3 is 5. 5 is less than or equal to 9. That's true. Where your shading is correct. So your interval notation for this just goes from negative 1/2 to 1, including both of those numbers. So there should be brackets on both of them. If we look at our next set of examples, these are just equations. So absolute value equations do the same thing. Isolate the absolute value, see if it's possible. From there, give yourself 2 equations and solve them both. With these, you want to check for extraneous solutions. So plug in your answers, see if they work. If they don't work, it's an extraneous solution. For number 7, you have 7 minus the absolute value of 2x minus 5 is equal to 27. First thing we're going to do here is what? Subtract the 7 from both sides. So it gives us the opposite of the absolute value of 2x minus 5 is equal to 20. From here, we're going to divide each side by the negative 1. So we get the absolute value of 2x minus 5 is equal to negative 20. Is this possible? It's not. You cannot have the absolute value of something equal to a negative number. So if this is not possible, what's your answer? No solution. For number 8, you have 2 times the absolute value of 5x minus 1 is equal to 4. In order to isolate your absolute value, divide each side by the 2. So you're going to be left with the absolute value of 5x minus 1 is equal to 2. That 2 is positive, so this is possible. Separate this into 2 inequality, or 2 equations. You're going to have 5x minus 1 is equal to negative 2, as well as 5x minus 1 is equal to positive 2. For the one on the left, we're going to add the 1 to both sides. So you get 5x is equal to negative 1. Then divide each side by the 5. You get x is equal to negative 1/5. For the 5x plus 1 is equal to 2, add your 1 to both sides. You have 5x is equal to 3. Then divide each side by the 5. You get x is 3/5. So check these. The 5 times the negative 1/5 is negative 1. Minus 1 is negative 2. The absolute value of negative 2 is positive 2. So 2 times 2 is 4. That one's true. That one works. Check the 3/5. 5 times 3/5 is just 3. 3 minus 1 is 2. The absolute value of 2 is 2. 2 times 2 is 4. That works as well. So you don't have any extraneous solutions for this one. For number 9, you have the absolute value of x minus 6. Minus 6 is equal to negative 4. Move your 6 over, add it to both sides. This is going to give you the absolute value of x minus 6 is equal to 2. The absolute value of something is equal to 2 is a possibility. So separate this into 2 equations. You're going to have x minus 6 is equal to negative 2, as well as x minus 6 is equal to positive 2. Move your 6 over, add it to both sides. For both of these, you're going to get that x is equal to 4 and x is equal to 8. If you check the 4 minus 6 is negative 2. The absolute value of negative 2 is 2. 2 minus 6 is negative 4. That one works. If you try the 8 minus 6 is 2. The absolute value of 2 is 2. 2 minus 6 is negative 4. That one works as well. For number 10, we have 5 plus the absolute value of 2/3 x plus 1/2 is equal to 13. How are we going to move that 5 over? Subtract it from each side. The 13 minus 5 gives us 8. Is this possible? Yes. So we're going to have 2/3 x plus 1/2 is equal to negative 8, as well as 2/3 x plus 1/2 is equal to positive 8. Do you want to work with your fractions? multiply them by your least common denominator. If you multiply the one on the left by the least common denominator, that's 6. So 6 times 2/3 x gives us, the 3 becomes the 1, 6 becomes 2, 2 times 2x is 4x. The 6 times 1/2 is 3, and the 6 times -8 is -48. If we subtract the 3 from each side, this gives us 4x is equal to -51. Divide each side by the 4, and you get that x is equal to -51 over 4. For the 2/3 x plus 1/2 is equal to 8. Again, we can multiply by the least common denominator, which is 6. So 6 times 2/3 x is a positive 4x. Then the 6 times 1/2 is 3. And 6 times positive 8 is a positive 48. So we subtract the 3 from each side to give us 4x is equal to 45. Then we divide each side by the 4, and you get that x is 45 over 4. For number 11, you have the absolute value of 3x plus 4 plus 5 is equal to 3. In order to get our absolute value by itself, what are we moving over and how are we moving it over? You're going to subtract the 5 from each side. So this leaves us with the absolute value of 3x plus 4 is equal to -2. Is this possible? No. So because this is not possible, what is our answer? No solution. For our last one, number 12, you have the absolute value of 4x plus 3 is equal to the absolute value of 2x minus 5. Remember, with these, we have two absolute values, one on each side of our equal sign. So we're going to set up two equations, one that just doesn't have the absolute value of ours, and one that a negative is being distributed into either the right or the left side. For the first one, I'm going to keep the 4x plus 3 the same, but I'm going to distribute in a negative into the 2x minus 5. For the other equation that I'm going to form, I'm just going to have the 4x plus 3 is equal to 2x minus 5. If we distribute the negative on the left, we're going to have 4x plus 3 is equal to negative 2x plus 5. From here, I would move the 2x over, add it to both sides. This would give you 6x plus 3 is equal to 5. From there, subtract the 3 from both sides. You get 6x is equal to 2. And then divide each side by the 6 to get that x is 1/3. For the 4x plus 3 is equal to 2x minus 5, I would subtract the 2x over. This gives us 2x plus 3 is equal to negative 5. Then I would subtract the 3 from each side to give us 2x is equal to negative 8. And then just divide each side by the 2 to get that x is negative 4. So your two solutions for this one is the 1/3 and the negative 4.